would like to have a quick conversation with you around the business value of IoT and machine learning in logistics. And we are going to use the area of logistics for rail as the key element here. So we're going to focus all of our conversation. For those of you who don't know who we are and where we come from, we are, I hope you can see the next presentation, which is One Digital in a nutshell. We are a company partner of BigML, so we are an avid user of BigML, and we have multiple projects with customers using BigML. We are a systems integrator, if you wish, with 4 key pillars. One is cloud, the other one is IoT and machine learning, and then last but not least, security services that we provide to our clients in our geographic focus, which is Europe, by the way. So we have 3 central locations in Europe: Vienna, Munich, and Lausanne. We have our own cloud, which is, as mentioned before, part of our strategy. It's called exoscale.com. On top of Exoscale, we've installed BigML as a platform, and with that, we provide services to our clients. We have been selected by Gartner as one of the companies in the Magic Quadrant for IoT services, and that happened 2020. So, and this is basically, testament of our customer satisfaction and what we do for our clients. And of course, we are part of A1 Group, which is a telco. So we have a strong telco heritage in our background, and IoT and connectivity is a strong part of our business. So today we would like to guide you quickly through what we see as classic problems in logistics, and those problems are mostly related to the availability of assets. So what do we mean by that? Basically, when you have an asset, and that could be a container, a trailer, a truck, a vehicle of any kind, anything that you use for logistic operations. One of the key topics here is how to plan in an efficient and integrated way. How much of the asset availability can you provide? You don't want to have assets that spend time in repair or in maintenance or in transit. You want to have assets that are really effectively being used and are returning revenue and money for the usage that you have. So if you look at the optimization part of it, obviously you want to optimize your operational capacity. You want to optimize for route planning. You want to optimize also for demand visibility. And what that means is that you have, in the logistic planning, you have very little visibility. So you don't have a visibility over this demand spikes that may or may not occur. You don't have any, you have some sort of seasonal planning, but basically is you have your networks, your clients and their transportation networks, and this is what you know most. And this is more of a historical type of things, but you don't have really, people are not using a lot of machine learning for demand and supply chain. This is something new, what is happening currently. And then on the service operations, you may not have all the metrics and key performance indicators that are relevant for your services. So all of this requires really a lot of, it has implications on the customer engagement, has implication on the type of satisfaction that your customers would have, and implications on the way you can take care of the supply and demand that you basically cater to. At the end of the day, all of these processes, they come down to manual planning. There are a lot of people sitting together and driving manual plans and creating repetitive tasks and a lot of Excel sheets. And we believe that this can be done much better, right? So where we see a lot of impact brought through machine learning and IoT is in these areas of what we call this sense, predict, react, basically understanding what happens with the asset on the field, predicting what will happen with the asset, and then reacting to it by making use of some sort of recommender systems. In those cases, in all of those cases, you will have what we call the descriptive scenarios, predictive scenarios, and prescriptive scenarios. And I'm not going to read all of this, but there are a lot of opportunities for improvement. I mean, millions of opportunities of improvement in the areas of quality control, maintenance, logistic operations, asset operations. So that part will be pretty much relevant for the next level. of understanding how to use machine learning. So we're going to focus on one critical aspect of it. What we want to set as a focus part here is understanding how to integrate, how to create predictive applications based on platforms, and what should you do first, what should you use, what the customers basically should take as a second step and third step, so that they don't start running before they can walk and not start walking before they can crawl. So all of this is important. What do we recommend to our clients? We say, look, start preparing for business impact, start collecting the right data, start understanding issues related to data quality, issues related to platforms, select your proper partners, run your POCs, and only then you have enough experience to deal with machine learning and the right quality of data, which will allow you then to move to the next level, which is understanding the physical subsystems that are relevant to your assets. So if you have rail assets, as we are speaking here in this process, you will look into wheel bearing damage, you will look into flat spots, you will look into exhaust filters on the locomotives, you will look into closing doors, damage detection, and I think my colleague will speak after that, right, about this topic. Then once you have those subsystems very clear, you go to the asset management level. Now you're looking at the availability of the complete cargo wagon, you look at the availability of a complete train, the availability of secondary assets, and here you can detect anomalies, and you can start doing condition and condition-based and predictive maintenance, which is great. With that, you will go to the next level and go to the understanding the fleets as such, and the predictive demand components to that. So you understand what is the availability of specific assets and how can you load them and use them in the best possible way. And with that, you start optimizing the whole operations around your logistics. And then at the end of the day, you do then the strategic management decisions based on capacity utilizations and so on. What we are trying to tell clients here is not to go straight to the digital twin of whatsoever, because that's not going to give them any value if they don't understand how to solve the basic problems around machine learning and around IoT. And so one thing is, which is really, really important, is to understand that many of them, they already have systems of sorts. They have SAP systems or ERP systems in general, could be from Oracle, from SAP, from any other vendor. They have CRM systems, they have logistic planning systems, enterprise asset management systems. That's all good. But what happens here is that those systems are systems of records. In those systems, you have transactional data, you have master data, but you don't know what exactly happens in the field. You don't know how this asset exactly right now is behaving. You don't know what kind of, let's say, temperature, load, voltage, whatever important physical characteristics is to be measured. You just don't know that. Those systems were not created for hosting this type of information. And so what we tell our customers is take care of creating IoT platforms or using IoT platforms, implementing machine learning platforms like BigML, for example, and that will allow you to build then platform-based predictive applications that will give you a repeatable impact at low costs. And why? Because you then achieve economies of scale. And economies of scale here are super important. So the more applications you build, the faster you are, the better you are. But you also reach economies of scope, meaning reuse, and economies of skills, meaning your people need to learn only a special set of skills, but you don't need to jump from one platform to the next one. You focus on a couple of them and try to extract as much value as you can from that. So that's a long theory talk, but that's what we do. So let me give you some very specific examples on how we address those topics. The first one is when we talk about the real-time digital logistics, we say, okay, it's by connecting your assets and connecting your planning, connecting those assets to your planning, that's where you reach out really then the next level immediately, right? So on the one side, you have sensors, connectivity, and many other topics that you use to connect your assets. On the other side, you bring that information, I mean, location, status, conditions, and alarms, alerts, whatever it is on your assets, you bring that as part of your planning. And now you know where your trucks are going exactly in real time. You can relocate, you can replan, you can do whatever needs to be done to optimize your planning. The next level in terms of maximizing the usage of assets is to take care of, for example, what happens on what many companies are doing, which is putting all assets in one enterprise asset management system and connecting all those assets to that enterprise asset management system. By doing that, you have a full transparency and full visibility of the current conditions, current status of your assets across the complete enterprise, across all processes, and across all transportation networks. That gives you the ability to plan your maintenance, to optimize your costs. And we are talking here about a lot of millions of savings that can be achieved if those connected assets and the information they transmit get as part of the processes. So let me give you an example. You may have what we call Edge ML. So this is a machine learning embedded into the assets, into the components of the assets, into the sensors of the asset that allows you to get real-time information about the condition of the asset, about temperature, about any other, any relevant physical magnitude that you want to measure. But when this information gets into the process side of the house, into your maintenance processes, into your inventory management, into your quality controls, that's where things are really getting interesting. That's when the real data goes through the business process part of your landscape, and that's where you can extract a lot of value from that. So for example, your people in the mechanical workshop, they would know ahead of time when a specific cargo wagon is supposed to return for repair and maintenance, and they can plan directly with the people in scheduling and in let's say quality control and suppliers that the spare parts arrive at the right time, that special quality controls are measured at the right time, and so you have an intelligent enterprise that is reacting to what happens on the edge, on the device, right? And what we are seeing is that this process of integrating enterprise asset management and enterprise assets together in one cyber physical system is not something that takes years to happen, but it takes even less than 6 months. We've seen this. And one of our clients, for example, CERN, the Large Hadron Collider, the particle accelerator, they have over 1.5 million, let me repeat this, 1.5 million assets in one single system. And so obviously the value that they extract from that is enormous. I want to show you a very different perspective now. Now we talked about the machine learning on the edge, and we talked about machine learning as part of business processes. We discussed this high level. Another trend that I want to go a little bit in depth is when we talk about the edge, what does it really mean? So basically, what kind of complex questions are we able to answer using machine learning, right? And IoT. So in one of those questions that we have been asked to solve or to address or to analyze is force distribution on a pantograph, right? So a pantograph is basically that device that allows you to take the power, the electric power from the from the catenary. And that's how, when you see a train moving, an electric train moving, it's this thing that has a contact on the power supply cable. And so the question that we had was, can we take real train data to understand the force distribution in the pantograph? And the question is actually why? Why should we do this? Why is that so important? And so I want to show you one small video to give you an idea of why this is important. It's a short video, but it's a horror video, so hopefully you'll like it. So you see here what happens when vibrations affect the pantograph. And this is a train running at 700, 600 kilometers, and 600 kilometers, 500 kilometers. So this is the length of the speed is 120 kilometers. And you see the destruction that occurs when things go out of, let's say, out of whack, right? I hope you could see this video. I don't know if you're able to see what happens here. So why is this important then? Because you want to avoid this type of situations. And what we are trying to do then basically when we have this specific element in here, we want to create a scenario in which we can predict complex data. So let's say coming from train, real train vibrations, and we can. What we did was we created a system using machine learning and using BigML de facto, which allowed us to predict basically vibrations. And for that, we used window average of specific vibrations and specific time series analysis. And we were able to predict with a high degree of accuracy, basically, the key elements of this force distribution signal. And that allows us to right now get to the next level, which is take this model, put this model into an edge device, and try to understand, predict basically based on a specific pattern of vibrations, what will be the next level of vibrations coming from here, and then anticipate any specific issues in vibrations out of your trains where the amplitude increases or where specific mechanical effects would affect the performance of the system. Okay, and so that's at a high level what the reason why, and the way we did this was using machine learning model for a regression on using decision trees and random forests and neural networks, so sort of an AutoML coming from BigML that allowed us to do this regression to predict basically the oscillations on the pantograph and understand much better the force distribution with a lot of parameters. We got a lot of parameters as input as features in our model. And I think in the next conversation, next 20 minutes, you will get more information on how this happens. So I want to leave you with some key topics that I think are important for all machine learning projects and all IoT projects. In logistics, as I said before, connecting IoT and machine learning with modern asset management systems is super important. And this is kind of the next trend what we are seeing, the creation of real cyber physical systems that go well beyond predictive maintenance and well beyond digital twins. Then the next topic is obviously looking at linking those integrated asset management systems with the logistic planning, so that now your logistic function planning basically, or your logistics operation, can take into account what happens with the asset management part. And last but not least, always remember that IoT and machine learning is a team sport. So you will have a lot of interactions between the business people that really know the topic and the specialists in machine learning and IoT, the technology experts, and they will help a lot in this case.